Top of the hour, so I think we'll go ahead and get started. So our speakers have a full hour. Thanks everyone for joining today on the symposium on math anxiety and the relation with math achievement. And I'm going to go ahead and hand it over to our organizer today. So whenever you're ready, Helene.
Hello, everybody. Can you hear me well? Yeah, that's great. Welcome to the symposium. I will start sharing my screen. Can you also see my screen at the moment? Okay, that's great. Today's symposium is about math anxiety in relation with math achievement from early childhood to adulthood. My name is Helene. I work as a lecturer at Utrecht University, and I will present the symposium together with Brenda, Jansen and Doctoral from Abertay University, and with Brenda Jansen from the University of Amsterdam. I will first give a brief definition of math anxiety, what are important consequences of math anxiety, and I will introduce our speakers. Math anxiety refers to the fear, tension, and apprehension that individuals experience when faced with mathematics. It is highly prevalent because our results indicated that 33% of the students experience helplessness while doing mathematics, and mathematics anxiety appears to increase with age during childhood. And as you might have seen already in the abstract of today, our talks also cover several age groups from early childhood to late adulthood. Math anxiety is also important consequences. About 14% of the variation in math performance can be explained by variations in math anxiety, and this has important academic consequences. It can lead to an avoidance of careers in the STEM fields, but also it has daily consequences and can result in less use of math in daily life. Today's talks will be as follows. Dawn will start with a presentation about the role of math anxiety in early years attainment, and she will offer an SES perspective. Then Brenda will present how anxiety for mathematics and reading in pre-adolescence are domain specific. And I myself will talk about how math anxiety is a mediator between gender and young adults' mathematical performance. I would like to thank the organizers of the MCLS for giving us the opportunity to present our work here. And the presentations of today will be around 12-15 minutes, which should leave some room for questions. And of course, also feel free to use the chat to ask questions so I can monitor that. And then I will give the floor to Dawn to start a presentation about the role of math anxiety in early years attainment.
Okay, well, hi everybody. I am Dawn Short, and I am about halfway through my PhD at Abertay University in Scotland. And as Helene said in her introduction, today I'm going to talk about maths anxiety, SES, and early years achievement. So, children's early academic performance is the best predictor of their later achievement, with early math skills strongly predicting performance in both maths and reading. We know that young children's early math skills remain quite stable throughout childhood, so children who struggle with number work at school entry can find it difficult to catch up with their more able peers. For example, Jordan and colleagues found children's kindergarten number skills predicted maths performance not only in grade 1, but also in grade 3. And Ten Brack recently reported kindergarten math skills to be a significant predictor of maths attainment when children were in grade 5. Therefore, understanding factors which affect maths attainment is important from the point children begin schooling, or even earlier. In Scotland, where children's math skills continue to fall, children from disadvantaged backgrounds are most affected, contributing to the academic attainment gap between those from richest and poorest homes. This pattern of results is also evident elsewhere in the world, and previous research reveals that it has long-term negative consequences. Several factors affect maths attainment, including individual differences and cognitive abilities. However, another factor we know influences attainment is family SES. For example, in a large sample of British families, von Stum found family SES when a child was 18 months old was a strong predictor of maths attainment at age 7 years and predicted attainment in the formal exams at the end of high school. However, in addition to individual differences, cognitive abilities, and SES, maths anxiety also has a role in maths attainment. I am sorry, I have got no idea why I've got this weird green line on my screen, so please ignore it. I don't know where that's come from. Anyway, so as Helene already explained, maths anxiety, but I'm just going to quickly recap. So maths anxiety is the extreme physiological and emotional response that sufferers experience doing or thinking about maths. And research demonstrates a link between maths anxiety and maths attainment, such that maths anxiety negatively impacts performance on maths tasks. But whether maths anxiety causes poor performance or poor performance leads to maths anxiety, or if the relationship is bidirectional, remains unclear. However, individuals with high maths anxiety typically have poorer maths achievement, which affects their long-term prospects. Therefore, maths anxiety is of concern and requires investigation. So Helene already touched on the prevalence and effects of maths anxiety in attainment. However, it might surprise you to know that there is already evidence of children having maths anxiety when they begin school at age 6 or 7 years old, and this is already related to their attainment. For example, Gunderson found a significant negative correlation between maths anxiety and maths attainment in 7-year-old children. They suggest that individual differences in maths skills mean some children lack the basic knowledge upon which to build later math skills, and consequently, they develop maths anxiety. Similarly, Harari reported maths anxiety in their sample of first grade children, aged 6 to 7 years old. Now, most studies look at children aged 6 years or older and tend to consider children of different ages rather than longitudinally. However, given that early maths attainment is predictive of later maths attainment and that maths anxiety is related to attainment, identifying maths anxiety earlier than 6 years old can be beneficial, especially where formal education begins earlier than this, such as here in Scotland, where children begin formal education the year that they turn 5. So the current study is part of my PhD work, and it is part of a larger longitudinal study investigating children's developing attitudes and their maths-related attainment. So we've examined maths anxiety of children from high and low SES backgrounds to see how it is related to their attainment during the first 3 years of formal schooling. So 2 consecutive cohorts of children from high and low SES backgrounds were recruited in Scotland in their first year of primary school. And as I mentioned already, it's important to note that children in Scotland begin formal education a lot younger than else in many other countries. So mostly in the year that they turn 5. So many of the children were only actually 4 at the time of the first testing. So participants were recruited from the same 4 local authority schools in Dundee in the northeast of Scotland. 75% of participants were from homes identified as low SES based on Scottish Government statistics. And the mean age of participants at first testing was 60 months. So the literature shows maths anxiety is associated with attainment. In addition, children's performance in school typically varies depending on their level of deprivation, with those from the least deprived homes typically having higher academic attainment than their more deprived peers. Therefore, the current study was interested in the relationship between maths anxiety and attainment for children from high and low SES homes. So participants completed a range of face-to-face tasks, including assessments of maths anxiety and maths attainment. So to measure maths anxiety, we use the Child Maths Anxiety Questionnaire, and there's an example question here. And maths attainment was measured using the WIAT standardized problem solving and numeracy subscales. Maths anxiety and maths attainment were assessed at 3 time points at the beginning of the first 3 years of primary school. Okay, so now let's have a look at the results. So here we have school year on the x-axis and numeracy score here on the y-axis, and we've got high SES in the green violins and low SES in the cream violins. So we can see at school entry, oh sorry, I've missed out the fact that we would, on these standardized tests of numeracy and problem solving, we would expect to see standardized scores of around 100 for children. And that's shown here by the blue line. So we can see that at school entry in year 1, there was already a significant difference between standardized scores, numeracy scores for children from high and low SES backgrounds. High SES children typically perform significantly lower than low SES children. So the high SES children were performing pretty much where we would expect for their age, but the low SES children were quite a bit below that. And this attainment gap expanded during year 2 and year 3. So there was a significant main effect of SES on numeracy score with a medium effect size, such that high SES children scored significantly higher than low SES children at all time points. And now if we look at problem solving, again, we have the school year on the x-axis, problem solving on the y-axis, high SES in the grey and low SES in the cream. And again, we can see the expected score level here on the blue, in the blue dotted line. So again, with problem solving, there's already a significant difference between scores for children from high and low SES backgrounds at the time that they began school in year 1. So the high SES children were again performing as expected for their age, low SES quite a bit lower. And similar to numeracy, we can see the attainment gap between high and low SES expands between years 1 and 3. And in fact, by the time that we get to year 3, we can see that the attainment gap is pretty much double what it was in year 1 for problem solving skills. So again, we find a significant main effect of SES on problem solving scores with a medium effect. Again, high SES children scoring significantly higher than the low SES children. Don't know why we're not going on to the next slide. Okay, there we go. Okay, sorry about that. So now if we look at maths anxiety and SES, where we've got maths anxiety score on the x-axis and percentage of children on the y-axis, we can see the maths anxiety here was coded such that high maths anxiety was considered to be mean maths anxiety score plus 1 standard deviation on the maths anxiety questionnaire, and low SES was less than the mean minus 1 standard deviation. So we can see in year 1 that 22% of the high SES children shown here in the red had high maths anxiety compared to 32% of the low SES children in the green. And then by year 2, we can see 24% of high SES had high maths anxiety and 41% had low SES had high maths anxiety. And then by the time that we get to year 3, we can see that the levels of high maths anxiety in the high SES group fell to 10%, and the levels in the low SES group was around about the same, still at 38%. So now if we consider the relationship between maths anxiety and numeracy, we can see there was a significant negative relationship such that as maths anxiety decreased, numeracy score increased. So although this relationship was stronger for high SES than low SES children. And similarly, if we look at the problem solving, again, we can see a negative relationship between maths anxiety and problem solving score, such that as maths anxiety decreased, problem solving score increased for both high and low SES groups. However, the relationship again was weak, and it was actually only significant for the high SES component. Okay, so now if we think about what we have found. So we found similar patterns of results for numeracy and problem solving. High SES children had higher levels of achievement in year 1, performing in the range expected for their age, whereas the low SES children had significantly lower performance, and this attainment gap expanded during the first 3 years. So although high SES children continued to make progress and showed gains on the standardized tests, low SES scores remained significantly below the expected levels, and the attainment gap increased to nearly twice its year 1 level. And more than a quarter of children self-reported high maths anxiety at school entry, when many were still only 4 years old. So we have to wonder why this is. Could it be the influence of carers, or could it be poor first experiences of formal maths when you start in school? High maths anxiety in the low SES component increased during the first 3 years of school, but the percentage with high maths anxiety fell in high SES children. So again, we have to wonder why. By year 3, only 10% of the high SES children reported high maths anxiety, but nearly 4 times as many low SES children had high maths anxiety. Although negatively related to maths anxiety for both numeracy and problem solving, the relationship with attainment was weak, but it was stronger for the high SES than the low SES children. So it could be that children performing at higher levels in maths are more affected by maths anxiety. And previous studies do suggest this, that maths anxiety increases as children get older. So it's also the case that many of the children in the high SES group were working at a much more advanced level, so they're experiencing more challenging maths than the low SES children. And this could have increased the maths anxiety. And as more low SES children reported high maths anxiety, the maths anxiety attainment relationship could become more problematic over time, as higher levels of maths anxiety tend to be found in older populations in the current study. So the early maths anxiety evident here could be a precursor for maths anxiety in the later years of school. Therefore, steps to address maths anxiety should be taken in the first years of formal schooling or even earlier. So in conclusion, the current study adds to existing work by identifying the presence of maths anxiety related to attainment in children as young as 4 years old in Scottish schools. Over the first 3 years of primary school, maths anxiety increased in low SES children but reduced in high SES children, and the attainment gap expanded. As we see maths anxiety increasing, we are concerned about what this means in the long term. At the moment, the evidence is inconclusive about how it affects attainment, but given other research, it may have greater effects later in maths development. And as previous research demonstrates, the long-term impact of increased maths anxiety, we need to consider if this high maths anxiety will have long-term effects on children's maths learning. Okay, that is me. Thank you for listening, and I can take any questions now. Or I don't know if you want to wait and have the questions at the end.
No, I think it's a good idea to invite people to ask questions. So if you have a question for Dawn, feel free to open your mic or to ask it via the chat. Thank you very much, Dawn, for this very interesting presentation.
And just trying to come out of the...
Is there anyone who would like to ask a question? Yeah, I would be interested to know whether you have any suggestions of how we could decrease math anxiety already in very young children.
Well, I think a lot of it has to do with the messages that children are getting from carers. I mean, as I said at the start, this is part of my PhD. Included within it, I've also looked at maths anxiety in parents and in teachers. And it seems like the parents, regardless of SES, there seemed to be a similar level of maths anxiety. So I don't know if it's that the high SES parents are more aware of their own anxious feelings, so then sort of take steps to avoid passing on how they feel about maths to their children, whereas that the low SES parents tend to say in their children's hearing, you know, oh, well, maths is too hard, don't worry if you can't do it. So they're sort of reinforcing maths anxiety in the children from a very young age. So perhaps something that tackles the maths anxiety in the parents at the preschool level might be useful. Don't really know. It's, yeah.
Yeah, I think that's an excellent suggestion.
But also the teachers, like, you know, also when I was going into the schools, I would have teachers saying, oh, you can take, you know, you can take this child because, you know, they're rubbish at maths anyway, so it doesn't matter if they miss the lesson. And you're having that reinforced by teachers saying that in the hearing of a 4-year-old child. You know,
yeah.
I think, well, that's kind of reinforcing that message from the teacher when they've only been in school a few weeks and already the teachers have decided that they're, you know, they don't have any maths skill.
Yeah, definitely. Yeah, that has a huge impact. Is there anybody else who would like to add something? Okay, then I would like to thank you very much for this great presentation. And I think we could move on to the next speaker. Of course, if you have any questions in the end, still feel free to ask them and feel free to use the chat. But otherwise, I will give the floor to Brenda.
Okay, thank you.
Thank you. Thank you, Helene. Yes, I would like to present some research that I conducted together with Delphine Zazanque, Charlotte Lamusseau, and Fien de Pape. And I would like to explain in this presentation why we come to the conclusion that anxiety for mathematics and reading in pre-adolescence is domain specific. And the background of the research is that, well, as was explained already, we know that some children experience anxiety when learning to do math, but also some other children, or maybe the same children, are experiencing anxiety when learning to read. And is this because there are specific domain-specific anxieties, or can it all be contributed to test anxiety, because learning to read and learning to math have a lot to do with being evaluated? Or is there some general academic anxiety? And the reason, or another reason for this investigating this, is because of the similarities between the anxieties. So Helene explained, and Dawn also explained, the definition of math anxiety. And what I want to show here is that there are 4 components of the anxiety. So there is the affect, so the feeling of being anxious; cognition, like thinking you won't succeed, that you're rubbish at math, for example; physiological symptoms like a headache or trembling hands or increased heartbeat; and the behavior, for example, avoiding any math problems. And the definition then says it's a negative emotion when one being confronted with math or when anticipating this. And that is very similar, I think, to the definition of test anxiety, because test anxiety has the same components. And in this case, they occur in a situation in which academic performance is evaluated or when anticipating this. And it's also very similar to the definition of reading anxiety. I think the only difference is that this then concerns situations that require reading. And in all these for all these anxieties, it is the case that there is a negative relation between anxiety and performance. And of course, we're not the first to note that there might be an overlap between these anxieties. So there have been several studies that investigated the relations between test anxiety, math anxiety, literacy or reading anxiety. There is less literature on reading anxiety, actually. So we also looked at literacy anxiety and general anxiety. So if we look at the literature for math anxiety, we see that there is quite a strong connection between test anxiety and math anxiety, and a weaker connection to general anxiety. There's also a link with literacy or reading anxiety. But what I think is interesting is that, or all is interesting, of course, but what we see is that there is a relation, the negative, significant relation between math anxiety and math performance. But there's also a weaker, but still, well, a significant relation between math anxiety and reading performance found in the literature. So is that because maybe the anxieties overlap, or the performances or the skills that are needed for math and reading performance overlap? It's interesting to disentangle this. There has been less research on reading anxiety, but there has been some research, and that also shows again the significant negative relation with performance, but also a relation with general anxiety. And general anxiety is also related to reading performance. So there's a lot of there are a lot of correlations, and what we think is missing in the literature is a study that really combines assessment of test anxiety as well as reading anxiety and math anxiety, and at the same time also assessing the performance in both reading and math. So that's what this study includes, although the data on reading performance are really limited. I must warn you already about this. And we would like to answer the question, can test anxiety, math anxiety, and reading anxiety best be considered as aspects of a general academic anxiety or as separate constructs? Well, to investigate the question, we have, or actually Delphine has collected data with 776 children. She did this together with her bachelor students in Flanders, Belgium. Some data were removed, especially of children who suffer from dyslexia or dyscalculia, or who followed special education for math because we were interested in the typical developing sample. And we also excluded data of questionnaires if children missed more than 10% of a questionnaire. So we ended up with 754 children, and they were divided into two samples, sample A and B, because we will do a confirmatory factor analysis and wanted to cross-validate our solution. And the average age of the children was almost 11 years. This is an overview of the material that we use. So on the left, you see the anxiety measures. For test anxiety, we use the subscale of the Dutch schoolvragenlijst. So it's I think it's the SAKI in English. So self-confidence during tests. We also use the child math anxiety questionnaire by Ramirez to assess math anxiety. And we translated it for this study to Dutch. So this was also the first time that the questionnaire was used in Dutch, as far as we know. And we adapted the child math anxiety questionnaire to a reading context, which resulted in the CRAC, which is quite of a funny name, I think, and of course also translated to Dutch. Yeah, and Don showed you an example of the CMAC, and then yeah, it was really literally or directly adapted to the reading context. For math performance, we have two measures. So one is tempo test math. So it's a speeded test where we ask children to solve as many math problems as they can in 2 minutes. And we also have data from the national tracking system or monitoring system. And we asked for the results of the current grade, so grade 5, but also of the grade of 2 years before that, so in grade 3. And then for reading performance, we have data also from the national tracking system for reading comprehension. But as you can see from the numbers, we only had these data from very small samples or subsamples. This is our statistical approach. So the first thing we did was that we tested whether either a one-factor model or a three-factor model fit best. So in the one-factor model, we had one general academic anxiety factor, but in the three-factor model, we had an anxiety factor for each type, for each domain, and we expected the questions of the specific questionnaire to only load on that anxiety factor. So we use cross-validation and use the Satora-Bender chi-square because the data are not normal, and this technique is not very sensitive to that. What we also did was, so we selected the single factor or three-factor model and then tried to optimize model fit by deleting items with low standardized factor loadings. And we did this for the 2 samples and also for the total sample. And then for the total sample, we looked at internal consistency, so both Cromwell's alpha and the composite reliability of the factors. We looked at convergent validity using the average variance extracted. Well, this is a lot of text, but we did hierarchical regressions to statistically predict the performance measure using the anxieties. So we compared whether the anxiety in a specific domain combined with the other anxieties was a better, no, sorry, I should say this differently, but if the prediction of all anxieties together was better, then we only included the anxiety for the specific domain. Okay, so yeah, I will go through the results quickly, but we selected a a three-factor model, and you can see the fit measures over here, and they're acceptable. And this is for the total sample after also item deletion for low standardized factor loadings. Well, this is a very detailed picture, but it shows the 3 factors. And I think you can see in a glimpse that the factor loadings are all substantial. These are the internal consistencies in the first 2 rows. So first traditional Cromwell's alpha, and then second column is composite reliability. These are all good. Average variance extracted is a little bit low, especially for test anxiety. So yeah, we think it's about acceptable for math anxiety and reading anxiety. And then these are the linear regression models, and yeah, let me walk you through it. So what you see on the upper level or upper half is are the math performance assessments. So what we see here is the TTA, so that's a speeded math test, and the hierarchical linear regression resulted in the inclusion of all the anxieties. But when we look at the beta coefficients, it shows that math anxiety was the strongest predictor of performance, but well, test anxiety also contributed. And then for the national tracking system in grade 3, only math anxiety was included in the model, and it had about this, well, I think the size of the correlation is a bit similar, also similar to what we often find in the literature. And for 2 years later, well, actually for the current moment, all 3 anxieties are again included, but math anxiety is the strongest predictor, although test anxiety also predicts performance. And then in the lower half, you see reading anxiety predicting reading performance or reading comprehension, and only reading anxiety was included, and it has this significant negative relation of the size that we, I think, often see in the literature. So to conclude, the model with 3 anxiety factors fits best, and together with these anxiety performance relations that seem strongest within a domain, which you saw in the previous slide, we would like to conclude that test anxiety, math anxiety, and reading anxiety can best be considered separate constructs. But well, you've seen also that there are correlations between the anxieties. I would also like to mention that this adaptation of the CMAC and the adjustment of, well, the translation to Dutch and the adjustment to the reading context seems promising. So it's, yeah, worth it, I think, to continue research with these tests in Dutch language countries. Of course, there are some limitations, and first of all, very limited data available on reading, and so that's something to address in future research. But I also think it would be interesting to go beyond self-report of math anxiety, and also to take a developmental perspective, actually, as Dawn did, and also to see how math anxiety and performance develop, and how the relations might change over time. So this was my presentation. Thank you for your attention. And if you have any questions, please let me know.
Thank you very much, Brenda, for this very nice presentation and presenting this nice research. There is a question in the chat from Ilse Kohler.
Yeah, I see
it's
it.
about, yeah.
It's about the linear regression model. Yeah, so I realized I went a bit fast here. So sorry, I'd like to go back to this slide. And so we fitted several models. So one model with only reading anxiety predicting reading performance, and then a second model, math anxiety predicting reading performance, and test anxiety predicting reading performance. But crucial is that we also had this fourth model, which included reading anxiety and math anxiety and test anxiety, and then looked at whether the whether the description of the model was significantly better, and that was not the case. So that's why we selected a simpler model, only including reading anxiety as a predictor. So we did try all the predictors, but then we, based on the fit measures, we selected either the model with all the anxieties as predictors or only reading anxiety. So I hope that answers your question.
Yeah, I think that clarifies the question. Okay, Ilse also says thanks. Is there anybody else who would like to ask a question in the chat or by opening your mic? I was wondering, did national tracking system also include mathematical word problems, for example? Do you know about that?
Yeah, that's a good question. Yeah, I should actually look it up, but yes, in theory there is a test that includes word problems as well.
Okay.
And maybe you're asking because there's a lot of reading involved, of course.
Yeah, exactly. Do you think if it would be like, especially mathematical word problems, that the correlation would be stronger?
That's a very interesting question. I haven't looked at that actually, but yeah, it's a very relevant question. So yeah, I will look at it. Yeah, but the interesting thing is that reading anxiety is not predicting that performance. So, but sorry, I need to look it up. Thank you for your question.
Okay.
Yeah.
Oh, there's also another question by Frieder Schillinger. Given that there is a variety of questionnaires assessing math anxiety in children available, could you elaborate on your choice?
Yeah, we chose this one because I think it's an easy questionnaire. So I think and maybe that's also the reason why Dawn used it, because it has more pictures and it doesn't require a lot of reading skills, I think, to answer it. I don't know, Dawn, would you like to add to that?
Yes, I agree. I mean, in fact, what I did with my participants was I made the questionnaire into a PowerPoint presentation, and then they saw the images from the test on a screen, and then they had to choose a face that represented how they felt about each of the given scenarios. Because, as you say, it's less reading, and because the children had only just started school, so a lot of them were only 4, you know, they had very little in the way of reading skills at that point.
Yeah, and I also think that, for example, the AMOS is much more focused on secondary school. So I think this really fits with primary school children.
Yeah.
So
yeah, definitely. Yeah.
Thanks for clarifying. Also, Frieder says thank you. So I think that clarifies the question. Okay, feel free to keep asking questions in the chat. In the meanwhile, I'm gonna start my presentation. You can see my screen now, right? I only have this. Okay, I think now it's better. And then there is also a question from Colleen. Maybe we can answer that before we move on to my presentation. The CMAC has math problems in it. I wonder how that impacts anxiety levels reported across age levels, since Dawn used it with very young children and Brenda's sample was with older children. Would you maybe answer that question?
well, I think it's an empirical question, or maybe we should combine our data, Dawn, and see. I don't know. Yeah.
Yeah.
Yeah, that could be really interesting. Yeah.
Yeah.
Thank you, Colleen, for your interesting suggestion. Maybe also at the end of this symposium, we could talk a bit about that. Okay. Do you see my screen now? Okay. I will start my presentation about math anxiety. The study we showed that it was mediated between gender and young adults' mathematical performance. This was a study conducted in collaboration with my colleagues Mila Marinova, Sarah De Leon, Delphine Sassanqui, and Bert Reinroth. And first of all, I would like to clarify why we why we would like to examine gender differences in math performance. Well, one of the reasons is that women comprise nowadays 35% of the students enrolled in higher education STEM degrees, so they are still underrepresented. And this raises the question, is there a gender imbalance in STEM education due to differences in math ability? Well, if you look at previous research, it actually shows that this might be dependent on the task that is presented. For arithmetic performance, a meta-analysis has been conducted examining whether men and women differ with regards to the arithmetic subtest of the Wechsler intelligence scale. And when it comes to adult men, they indeed perform better than women, but this difference only emerges around adolescence. For mathematical word problems, also it has been found that men perform better. Here I especially focus on the cognitive reflection test. This is a test where participants see a mathematical word problem, and this brings an intuitive answer to mind. But if you want to perform correctly on this task, you need to reflect a bit longer to come to the correct answer. And men also perform better on the CRT than women. This has been shown in several studies already. And then you have also number series tests where participants have to complete a number series or they have to verify whether number series are presented in the correct order. And actually very limited research has been done on this so far, but like a study in the 80s has shown that there were no gender differences with regard to number series tests. Then there are also several factors that could possibly underlie gender differences. One of them is working memory. Here I show the well-known working memory model of Beddeley and Hitch, which assumes that there is a central executive that coordinates information in the slave systems, namely phonological loop, episodic buffer, and visual spatial sketchpad. The phonological loop is responsible for the storage and manipulation of auditory information. The visual spatial sketchpad is responsible for the storage and manipulation of visual spatial information. And then the episodic buffer makes sure that the information between the several slave systems is well adjusted to each other. Also, math anxiety could possibly underlie gender differences. It's often assumed that when you experience symptoms of anxiety and you have to perform a task, that this occupies your working memory and therefore you perform poorer on the task. And gender-related stereotypes might also play a role. So the belief that math is maybe for males and not for females might result in lower mathematical performance. In the current study, we try to see whether the gender differences are present for 3 mathematical tests, namely a arithmetic test, cognitive reflection test, and a number series completion test. And we also studied the role of working memory, math anxiety, and gender-related stereotypes with regard to their impact on math performance. Of course, a lot of work has been done already on gender differences on math performance, but mostly these studies focus on one possible underlying factors and not on 3 as we do here. And often they also include only one mathematical test, while here we include 3 different mathematical tests. In the study, 189 participants participated. The study was conducted online and 90 men and 99 women participated. The mean age was around 23 with a standard deviation of 3, and the age range was between 18 and 35. Important is that men and women did not differ with regard to educational level. So we conducted a chi-square test, and this showed that there were no differences with regard to educational level. And participants performed 3 mathematical performance tasks. One was the template as arithmetic that Brenda also briefly mentioned in the presentation. Participants see several mathematical problems. Actually, in this version, they had 5 minutes to solve the task. So there were 5 columns presented, one with additions, one with subtractions, one with multiplication, one with divisions, and a column with mixed operations. And participants had 1 minute to solve as many problems as possible on each column. And this is an example item. Then participants also performed a cognitive reflection test. They saw several questions and they have to give an answer. An example question of the cognitive reflection test is: a bat and a ball costs $1.10 in total. The bat costs $1 more than the ball. How much does the ball cost? And they performed a number series completion task. They saw 3 and, well, it could be 3, 4, 5 numbers on the screen and 1 question mark, and they had to indicate which number needed to be placed on the place of the question mark. Participants also performed working memory tasks. They performed a digit-span forward task and a digit-span backward task. The digit-span forward task steps into the phonological loop component of working memory, and the digit-span backward task steps into the interaction between the phonological loop and central executive, because participants not only have to store information, but also manipulate the information. So they saw a sequence of digits, and after the digits had been shown on the screen, they had to recall them in the correct order, in the forward span task, or in the reverse order in the backward span task. And during the task, the sequences became longer. A similar task was done with matrices, and the matrices span forward task steps into the visual spatial sketchpad component of working memory, while the matrices span backward task steps into the interaction between the visual spatial sketchpad and the central executive. And here participants saw a grid with one black square, and they saw several grids, and in the recall phase they had to indicate where they saw the black square appearing on the grid and in which order. And for the matrix span forward task, they had to do this in the same order as they saw it, and in the backward span task, they had to recall this in the reverse order. We also measured participants' math anxiety. They had to indicate for several items how nervous they would feel. For example, having to use tables in the back of a math textbook. They also had to indicate whether they considered certain activities as a typical male, typical female, or as an activity that could be done by both males and females. And implicit gender-related stereotypes were measured by an implicit association test. Here there were two boxes, and participants either had to group male and liberal arts words together, or male and science words together, or female and liberal arts words or female and science words together. And they had 10 seconds to group as many items as possible in the box. Here you have congruent items, so it was congruent when male and science words had to be grouped together, and female and liberal arts words had to be grouped together, but it was incongruent if it was the reverse, as you can see here in the example. So far about the tasks. Our results showed that for the arithmetic performance task, there was a correlation with all the other tasks, except for the implicit association test. For the cognitive reflection task, we saw that it only correlated with math anxiety and with the matrices span backward task, which steps into the visual spatial that component of working memory and interaction with the central executive. And the number series completion tasks correlated also with a few working memory measures and with math anxiety. When we then look into the gender differences, we see that participants perform, or while men perform better on all the mathematical performance tasks compared to women. This was the case for the tempo test, arithmetic, cognitive reflection test, and number series completion test. We found no differences with regards to working memory. So here we see that men and women perform similar. This was the case for all the working memory tests. We do see that women reported more math anxiety than women. They also, there was a difference in how they reported explicit gender-related stereotypes, with men having a tendency to weight certain activities as more masculine. And there were no gender differences with regard to implicit gender-related stereotypes. And then we looked into whether these underlying factors could mediate a relation between gender and mathematical performance. We only included these factors in analysis when there were actually gender differences and when there was a correlation with the mathematical performance task. So for the arithmetic performance test, it correlated with math anxiety and explicit gender-related stereotypes. And these were also factors where we found gender differences. So therefore we included them in the mediation analysis. And we see that math anxiety was a mediator, but explicit gender-related stereotypes were not. The cognitive reflection test only correlated with math anxiety. It also correlated with working memory, but there are no gender differences were found. So we only included math anxiety in the analysis. And we saw that math anxiety was a full mediation between gender and cognitive reflection. And then a similar result was found for the number series completion test. Also here we see that math anxiety was a full mediator between gender and number series completion. From these results, we conclude that there are gender differences for 3 different mathematical tasks, but not for working memory. So it seems that math anxiety plays a central role in the relation between gender and mathematical performance in young adults. And this possibly reflects beliefs about mathematics, because it seems not to reflect differences in working memory capacity, as men and women perform similarly under working memory tasks. I would like to thank you for your attention, and I would be happy to hear about your questions or questions about the other presentations. Oh.
Can I ask a question, Helene?
Yeah, sure.
Maybe I missed it, but what was the background of your participants?
It actually, we recruited, you don't see my screen anymore, right?
Yeah, we do.
Okay, I know it's better.
Not anymore, yeah.
Okay, I basically asked my students to recruit participants in their environment. Most of them were fellow students, but sometimes it was also a bit older participants who already worked, and so it was a bit of a mix of participants between 18 and 35 years old.
Okay. Yeah, I think you have very interesting results, and well, thank you for your interesting presentation. And yeah, I was just trying to get my head around it. Why are there gender differences in these math performance tasks? I didn't expect them, that they would still be there.
You would maybe think that by the time of adulthood, it would not be present.
Yeah, maybe.
Yeah.
And then they were present in all the tasks, right?
Yeah, yes, we also thought that that was interesting. We thought that there might be a difference maybe between the different mathematical tasks. Yeah.
Yeah. Can you explain it? Why you saw the differences in all the tasks?
I think in this study, it's probably related to math anxiety. I think because they're also fairly complex tasks, all of them. So it would be interesting maybe to see whether for more simple tasks it's not the case anymore, like really basic numerical comparison tasks, for example, or.
Yeah.
So yeah, I think when it comes to more complex tasks, women seem to be more stressed and anxious about it, which results in a lower performance on this task.
Yeah, and on the other end, I think the TT, what is it? The tempo test is not that difficult, but it has a speed. What is it?
Yeah, indeed. Yeah, I also had the impression that that affects a bit women's performance. Would be interesting to see whether it would not be the case if there would be no time limits. So if you adjust all the time of the world to solve it, yeah.
Thank you.
Thanks. Well, I have a quick look in the chat, but I don't think there are any questions there. But if you have any questions for me or for the other speakers, feel free to ask them there. And otherwise, I would like to thank you very much for attending this symposium. And of course, thank you, MCLS community, for always organizing these meetings and for giving us the opportunity to present here.
Yes, thank you so much to all our speakers today. And just as a reminder that next week, our symposium is on Thursday on caregiver math beliefs. But thank you all for a great symposium today.
Thank you. Enjoy your weekend and looking forward to see you next week.
Thanks, everyone. I'm sorry again about the drawing. I don't know what happened with that, but thank you to whoever fixed it. Someone was messaging me on how to fix it. Like, I don't know how to do this or how it happened. So sorry.
Yeah, I was a bit afraid it was me. Was it me? Because
I have no idea. I think it might have been me too. I have no idea.
I thought it was a Mariah.
Oh, maybe. I'm not sure.
Yeah. Anyway.
I've never seen that before, so people were saying how to fix it. So anyways, but
yeah, that was helpful because I was able to fix it after somebody mentioned that. So that's why I was thinking, oh, maybe it was me. I'm sorry. I was a bit struggling with everything getting set up, and then maybe I made a line on the screen. I'm not sure.
Yeah.
Is that a problem for when you compile like the video? Because you always put this on YouTube, right?
Right. I'm not sure. Andy usually does the export to video, so I'm not sure if it will be on there or not. But I do think it didn't seem like it was covering too much of the stuff. I think people were able to.
I just wondered where it had come from. I thought I had done something.
No, so I don't think so. I'm not sure where it came from, but
go well together.
But I guess now I know how to fix it in the future if that ever happens, but I apologize for not being able to do it sooner. So you all did great.
Okay,
thank you for hosting this.
Yes.
It was nice.
Have
a good day. We will start on our weekends.
Okay.
Yeah.
Have a great weekend.
Yeah, have a good weekend, everyone.
Have a good weekend. Bye.
Bye. Bye.